Hi everyone, we're going to get started. My name is Sarah, this is Meta, Masha, and Alexis. We are the executive directors of SHE256, and I want to welcome all of you guys. We have high schoolers, college students, industry professionals, and some amazing women here today.
So the goal for SHE256 is to highlight and connect communities that's in the blockchain industry that strive for inclusion, equality, and professionalism. And that's why we've created a conference to gather like-minded individuals and organizations to achieve that goal.
We want to empower new faces to enter the blockchain industry by featuring the groundbreaking research, protocols, and specific applications of blockchain led by women in the space. Women are already doing cool shit, and we're going to keep doing cool shit.
Fortune 500s, governments, and even ordinary people have invested billions of dollars in this space. Yet there are still so many open problems to be solved. Today, you will hear from visionary leaders solving these cutting-edge problems. Yet, as I said before, there is still so much to be solved. So we hope you can come away from today learning something new and being inspired to go ahead and take those next steps to solve that breadth of open problems.
Because the blockchain space is still in its infancy, we have the unique opportunity to set the culture and tone, which is what we're here to do today. There is nothing like this particular place, time, or industry that has ever existed into the past, which gives us this unique position to set a precedent for the future.
We're so excited to announce that this year we've launched a scholarship program for high school girls, specifically focusing on young women from low-income and underrepresented backgrounds to attend the conference and learn more about blockchain. If you're a scholarship recipient, welcome. We're so excited to have you here today. Blockchain is a disruptive technology, so let's disrupt the industry with more diversity.
Our first speaker is Aparna Krishnan, giving an introduction to blockchain. Aparna is the co-head of education at Blockchain at Berkeley and teaches a blockchain fundamentals course, one of the largest blockchain courses in the nation, teaching over 100 students per semester. She has taught executives globally and in blockchain executive education and leads the crypto economic research group at Blockchain at Berkeley and focuses mostly on researching alternative consensus. So please welcome Aparna Krishnan, who will be giving our technical keynote.
Good morning. How's everyone doing? Great. Okay. Who's excited to learn about blockchain at SHE256? Okay. So today we'll start by talking a little bit about the history and terminology surrounding blockchain. Understand the motivations as to why someone started this blockchain technology. And then we'll move on to an introduction to what blockchain is. And from there, we'll talk about Ethereum, smart contracts, and if we have some extra time, we'll get into how consensus works. So let's get started with some history and terminology. So a lot of terms that you hear in the blockchain space is often Bitcoin or cryptocurrency or crypto. And Bitcoin is the technology that started all of it. Bitcoin was started by Satoshi Nakamoto in an anonymous white paper, and that's basically where the term blockchain came from. I remember when Bitcoin first came out, there was no concept of blockchain. There was only concept of the blockchain because there was only one blockchain that existed, and it was the Bitcoin blockchain. Now, blockchain is the technology underlying Bitcoin that enables it to come to consensus. Now, a lot of other terms that you'd hear about in the community is crypto or cryptocurrency. Crypto in short for cryptocurrency, and it's meant to be more technical and refers to technologies like Bitcoin, Ethereum, Zcash, Monero, anything that's a digital currency. Other terms that you often hear is private blockchains or permission blockchains. Now, this is a term coined by businesses or financial institutions because they want to differentiate the term Bitcoin, and they want they want to keep themselves separate from Bitcoin and all the juicy drama surrounding it, but they still want to be able to use the blockchain technology, so they coined other terms like permission ledgers. Other terms you'll hear a lot are decentralized tech or just blockchain. And these are basically umbrella terms to refer to the whole space. So let's get started understanding a little bit about the motivations behind why this technology was created. So blockchains or bitcoins came out of this libertarian movement. There's a group called cypherpunks or crypto anarchists, and these are they're hardcore libertarians. So around the 1980s, when there was a lot of surveillance technology coming out, this group of people decided, well, hey, it's getting easier for governments to track us, but we don't want to be tracked because they're taking away all our privacy. Like with us developing all this new technology, people are able to take all of it and store all of this information about us. And they kind of predicted what might happen with Facebook today, or like the Cambridge Analytica today, where you track every human being's information. And in order to battle that, they said, you know what, we're gonna use cryptography to get back our privacy. So a lot of people might think privacy only for those who are trying to hide something about themselves? Is it only for people who are doing something illegal? But these people believe that privacy is the power to selectively reveal oneself to the world. And privacy in an open society requires some sort of anonymous transaction system. And they truly believe that everyone has the right to privacy. Privacy is not only for someone who's doing any kind of illegal activity. So how did this whole movement start? Well, it's not like someone woke up one day and said, here's the blockchain, here's the white paper, let's go. This was generations of work. So really early attempts at creating this sort of decentralized currency system started with DigiCash, where someone called David Chaum, who is like a magic crypto wizard, came out with this idea of blind signatures. And his contribution was basically, how can you represent people by public keys? So how can you have pseudonymous transactions? However, his idea of creating a digital currency failed because it was a centralized system which was minting currencies. So if you don't trust the banks, why would you trust DigiCash? So another thing about these crypto anarchists or libertarians is their biggest threat is banks and financial institutions and governments and centralized people who are trying to track you down and keep track of your data. So that's one of the main reasons that DigiCash failed. Another attempt was Hashcash. So in Hashcash, coins are minted and expended by expending some resources. And this was the first time someone came out with the idea of proof of work. So proof of work is something used in the Bitcoin blockchain, and you might think that's the revolutionary discovery of Satoshi, but no. Hashcash was the first one that came out with this idea and used this to battle spam email or spam bots or spam messages. So Satoshi basically took all these different innovations, looked at what was working really well in them, what was not, put them together in a system called blockchain, called the Bitcoin blockchain. And this was created in 2009 in an anonymous white paper. Well, does anyone know who Satoshi is? If you do, you'll probably be worth a lot of money. I'll pay you $1 million. And what Satoshi did was to create this first ever decentralized, trustless system for transactions. And all you need to join the system is an internet connection and a computer. What Nakamoto solved was called a double spending problem. So in any sort of digital currency system, you want to have a way to prevent someone from spending the same asset twice. And that, if you're able to do that, it's called double spending. And Satoshi used proof of work from Hashcash to be able to solve that in addition to the blockchain. And Bitcoin, by putting together all these different iterations, like anonymous transactions or proof of work, enabled a myriad of different possibilities. So all of this was great. Bitcoin comes out. People are able to mine Bitcoin. People are able to be part of this network. But what does that mean if it doesn't have any value? This is where Laszlo Hanyas made a difference. So here's this guy who is a gamer. He's using his CPUs to mine a lot of Bitcoin. And he says, well, you know, I have a lot of this. But if all the Bitcoin is only with me and with like 5 or 10 other players, it defeats the whole purpose of creating a decentralized system and having this money spread out with multiple people. So what he does is says, you know what, I'm gonna try and spend this Bitcoin for a real world asset. And he spent 10,000 Bitcoin on a pizza. Now, you might think, what an idiot, like 10,000 Bitcoin, he could be a billionaire, or like, that was worth a lot. But what he did was he gave value to this magic worthless internet money. By making this first transaction for a real world asset like pizza, people could finally think of Bitcoin as more than something you just hold on to, but now you can finally spend it. And this was the first ever transaction for an actual tangible asset of Bitcoin. So this is a slide that talks about all the different words you hear when in relation to blockchain technology. Anonymous basically means you don't know the person's identity. Decentralized, there's no single point of failure. There are multiple participants in the network. Immutable basically means you can't change the blockchain. Once whatever you've put on it is permanent. Consensus, well, because you have multiple people writing from this blockchain or reading from this blockchain, everyone needs to be in agreement of what's on the blockchain in the first place, and that's where consensus comes in. Global means anyone in the world can join into this network, be part of it. All you need is a computer and an internet connection. Trustless, there exists no form of trust in the system. All you need to do is understand that the math and code works well. You're not trusting any humans. You're not trusting any central organizations. And this is magic internet money. Wow. So we talked a little bit about history and terminology. Let's get started and understand what blockchain is. So what is a blockchain? Well, a blockchain is just a chain of blocks. And properties that the blockchain has is it's immutable, which means whatever you put on the blockchain is permanently stored. And it's a distributed ledger. What's a distributed ledger? Well, what do we mean by ledger? Let's start there. Ledger is just somewhere that you can store information. So you can store information like account balances, asset ownership, smart contract states. So if Alice has $500, that is something you'd store on a ledger. An Excel sheet is also a very simple example of a ledger. If you stored every single person's bank balances on an Excel sheet. But what is distributed? Distributed basically means all the different participants in the network are separated. They're not in the same spot. You might have multiple CPUs running. You have multiple places where you're having memory stored. And an interesting property about distributed is that these peers or these different participants in your network can act maliciously. Like they can arbitrarily stop responding to everyone. They can arbitrarily send wrong messages, or they can try and send messages out of order. And even when all of these crazy things are happening, your system must operate smoothly. And this is basically where blockchains can still continue to function, because if not, you can't have a distributed system and you can't trust everything that's going on. And this property is basically called Byzantine fault tolerance in a very technical academic sense. But why distributed? Why do you need it in the first place? Because there's no central point of failure. Do you trust your bank to not fudge your records? Like maybe today you have $500 in there, but what stops someone from going in there and changing your balance to $1? Currently, you trust that the bank is not going to do that, but maybe they would, maybe they wouldn't. But by having this distributed technology, you don't need to trust any one person. You can trust that if someone had to attack the network, they would have to attack every single person in the network, and that's a lot of cost. So you don't know for sure that they won't be able to attack the network, but you do know if they had to attack it, it would be like billions of dollars, the amount of money that not any single person in the world has. And why do we need distributed? Because this can support global scale applications, and this gives us the property of trustlessness, where you don't trust humans, you don't trust organizations, you just trust math and you trust code. And that code and math you can verify for yourself. And this also gives you another interesting property of uncensorable. So remember, the Bitcoin blockchain started with libertarian dreams, and these were people who didn't want any sort of censorship. Like if you receive a large amount of money into your bank account, they're gonna ask you where it's coming from, or they might stop that transaction. But in a Bitcoin system, you have no censorship. Well, what is immutable? Immutable means whatever data you've put on the blockchain cannot be changed, and it's committed onto that ledger forever. And the entire group of people or the entire network must come to agreement on what this new updated ledger is. So when people make transactions in the network, they must all be in agreement on what this new updated current version is. So how can you do all of these things? That's where the concept of cryptographic identity comes in. So just like in the real world, on an email account, you're represented by your username and password. On the Bitcoin blockchain, you're represented by a public and private key. And this is your cryptographic identity. This is what provides you this property of pseudo-anonymity. So when people think the blockchain is anonymous or pseudonymous, it's because your name or your passport or your social security number is not on there. Like no one knows for sure that it's you, but they see a string of digits or a string of numbers that represents you. And this cryptographic identity, or this pair of public key, which is your username, and private key, which is your password, enables you to spend and receive Bitcoins. So only the person who has the password can spend that money, and only the person who has your public key can send you that money. So we've used this word consensus a lot, but what does consensus mean? Think about it as if I had $50 in my account and I sent Alexis $10 and then I sent Meda $60. The transaction ideally shouldn't go through, but what is the order in which the transaction should go through? Should I be able to spend that money to Meda first, or should I send that money to Alexis first? How does the entire network agree on what that final state of my account looks like? And that's what it means to come to consensus. Because remember, everyone's separated by the internet, and everyone receives messages in different orders. But how do they all agree on what the right order is and what the final balance on my account is? And that is what we mean by consensus. We also want other interesting properties of replication and fault tolerance. What that means is, even in the case of like if I was a miner and if I lose internet connection, or there's a power shutdown in America and all the people in America lose power, the ledger shouldn't go offline. Like, we should still have the records of everyone on the blockchain there, so that when we go online, it's still reliable and we can still use it. So how do we use we reach consensus? Some common consensus protocols are proof of work, proof of stake. Proof of work is what the Bitcoin blockchain currently uses. Proof of stake, if you've heard of it, is what Ethereum is going to switch to later on this year. And each of these different consensus protocols have trade-offs. So you can think of things like, should you be able to handle people being offline versus should you be able to handle people who are sending messages out of order, which is more important to you in your blockchain system. And that's what it means to think of consistency versus availability. And other trade-offs you have are, do you want a public or private blockchain? Do you want anyone in the world to be able to join your system? Or do you want to be able to pre-select the people in your system? So what was this innovation that Satoshi came up with? So in traditional distributed systems, you're not able to handle malicious nodes, in a sense. So if someone acts arbitrarily, you might not be able to handle it. But in the blockchain, you're able to do that, and you're able to allow anyone to be part of your blockchain system. And that is essentially the innovation. So in a traditional system, you can only choose pre-selected people to be part of your system, and you can only tolerate some kinds of faults. And in a blockchain system, you're saying, you know what, everyone who wants to join, please join, and I can handle any kinds of faults that come up. Or many more kinds of faults. So that's an introduction to blockchain. Let's talk a little bit about Ethereum. How many of you have heard of Ethereum? Cool. So let's talk a little bit about smart contracts. What is a smart contract? A smart contract is a written or spoken agreement that is intended to be enforceable by law. So notice here, nowhere does it say it has to be on the Ethereum blockchain. So all that you really need is some sort of agreement. It could be automated, it could be written on a piece of paper. So a smart contract is basically code that facilitates, verifies, or enforces the negotiation or execution of a digital contract. All you need is some sort of trusted entity to run this code. So again, it doesn't have to be decentralized, or it doesn't have to be on the blockchain. A lot of people think smart contract is only on Ethereum blockchain, but you and I, if we trust each other, can write up some code and run it on our machine, and that would be a smart contract. If we don't trust each other, but if we trust our friend Alexis, we can write the smart contract and have her run it on her machine, and we know it executes currently. But what the blockchain provides is that you don't even need to trust Alexis. All you need to know is that you have this entire network of people who are going to be running that code over and over again. So you have this concept of public verifiability. So in any network, or if any organization puts their code out for you to see, you don't know for sure that that is exactly the code that they're running. Maybe they've changed it. Maybe they're running an outdated version. Maybe they're running an updated version, one with trapdoors that accesses all your private information. But having the blockchain helps prevent that, because whatever code you put on the blockchain is run by every single person who's maintaining the network. And now, if you have to change this code, or you have to go back to a previous version, everyone on the network needs to agree that you have to go back to that previous version. So you can trust that no single person is going to fudge the blockchain contract. And this is how you have trustlessness, and this allows for these secure peer-to-peer agreements to live forever on the blockchain. And again, you don't need to trust any single third party. You can just trust the math and the code, as long as there's some good way to come to consensus. So let's talk a little bit about Ethereum and Ethereum's innovation. So this is Ethereum's homepage. And the way that they like to market themselves is by calling them a decentralized platform to run smart contracts, or the world's distributed computer. And this distributed computer is used to execute code. So every single machine that's maintaining the network is running this code. Ethereum uses what's called an account-based model, where it's basically like the most intuitive way to think about it is if I said you have $500 in your account, you have the person's key and the amount of money that they have. Bitcoin doesn't use that model. Bitcoin uses a more complicated system, which is called a UTXO model. So Ethereum uses a distributed state machine, and transactions can change this state over and over again. So the blockchain is basically an application of transaction on the current state, and then the state moves to a future state. Now, Ethereum also has a currency or a native asset called Ether, and this Ether is what gives value, or is the cryptocurrency part of Ethereum. And you need Ether in order to align incentives. So everyone who's maintaining the network has to expend some amount of electricity, or should have bought a computer, needs to pay for their internet connection, and they're not going to maintain the network for free. So you need to pay them in order to maintain your network, and that's why you need this asset called Ether in order to pay these people and keep them incentivized to keep the network in a good state. Okay, so contracts in a blockchain, like Ethereum, live on the network forever and act as these autonomous agents that live inside the network. So you can interact with these contracts through functions, and you can poke these contracts with any sort of functions that they have publicly. And you can access different things in that contract, like the internal balance of the contract, so how much money is in there, how much data is stored in there, any of the variables stored inside the contract. You can interact with the internal contract state, and also any sort of permanent storage. Okay, so let's see how we're doing on time. I think we're doing good. So we can talk about consensus, and then we'll go back to questions. But actually, does anyone have questions so far? We can do a couple questions. Oh, this one? Okay. All right. Are there any questions? If not, we can do the extra section and talk about, yeah. Doing something, right. So she said from a lawyer's perspective, you have to do something in exchange for money. Yeah, that's what contracts normally represent. So in the case of Ethereum, how do you keep track of doing something? And that's a very good question. So if you had to think about doing something in the real world, like did I water my plants? That's really hard to keep up in the Ethereum smart contract. But you can do something more limited in the financial setting of like, on this date, I promise to pay you this amount of money. And you can lock up your money, your Ether, into the smart contract, and on that particular date, the money will get sent to this other person's account. So simpler things, like a more restricted setting. Yeah, but once we do have sensors or like great IoT devices to record things like if this plant was watered, we'd be able to do other things like track real world doing of actions. Cool. If not, we'll move on to consensus and talk about proof of work. Okay, so you have all these different people in a system. And let's say Jillian makes a transaction to me. But how do we know it's valid? And how do we know that she's not cheating anyone? How can we make decisions on how to update the ledger? Well, one way we can do it is by when Jillian makes a transaction, she tells everyone in the network, hey, I sent Aparna 5 Bitcoin, and everyone says, okay, I'm gonna update my local copy of my ledger, which could be an Excel sheet, to Aparna has plus 5 Bitcoins and Jillian has minus 5 Bitcoin. But how do we know she's not cheating? What if Jillian says, I'm sending Brian 5 Bitcoin, but I'm also sending Nadir 5 Bitcoin. But Jillian has only 5 Bitcoin in her account. And this is what we called a double spend attack. Now, if Brian doesn't talk to Nadir, and if none of us in the network talk to each other, we're all in our little silos, we won't be able to prevent this. Or Brian's ledger would update Brian with plus 5 Bitcoin, and Nadir's ledger would update Nadir with plus 5 Bitcoin. What is the real ledger? Like, what should everyone in the network agree on? So obviously, that's not working. That means everyone in the network needs to be talking to each other. So instead of making decisions in a siloed fashion, we all decide, let's talk to each other, and based on our talks with each other, let's make a decision. So now when Jillian says, I'm spending 5 Bitcoin, she has to tell everyone in the network, but that's not enough. Everyone in the network also propagates that around to everyone else before they make their decision. And once they receive a certain number of votes from everyone else saying this is okay, they update their ledger. That seems fine, right? Except, so now when Jillian attempts to double spend, if I get 3 out of 5 votes, I know that it must be okay, so I can update my local copy of the ledger. Except, even that's not enough. Because what if Jillian says, okay, Aparna, I'm gonna take you down, and Nadir, I'm taking you down. You're both gonna become Jillian's little nodes. And now, when everyone in the network votes, it's actually Jillian doing most of the voting. So to Nadir, Jillian can send 3 out of 5 votes, and to Brian, Jillian can send 3 out of 5 votes. So Jillian can still perform this malicious activity and go through with her double spend attack. And Jillian creating multiple identities of herself is called a Sybil attack. And the reason Jillian was able to create multiple identities of herself is in any Bitcoin or blockchain system, what's your identity? It's just your public and private key. What's your identity in any email system? It's just your public and private key, or your username and password. How easy is it for you to create another email ID? All you need to do is create another username and password. And all Jillian had to do was create multiple usernames and passwords in order to vote on behalf of multiple people, and convince everyone in the network that her double spend is valid. So this means, oh yes. Yeah, so the way we've set up the voting, her question is, does Brian only need 3 or 4 out of 5? Like, does he need 5 out of 5, right? Or she just says like, so when I say she sent Brian the vote, it's like everyone in the network says I say yes or no on this is an okay update to the state of the network. And if Jillian has 3 out of 5 accounts, Brian's gonna receive 3 yeses from her, and Nadir is gonna receive 3 yeses from her. Does that make sense? Okay, so just to go back to the scheme that we're currently using, we have everyone in the network only updates their ledger if they receive majority yeses on their update to the network. So in this case, we saw Jillian created multiple identities of herself in order to send multiple yeses to people. So instead of making it easy for Jillian to send these yeses, we say we're gonna cast votes with resources. So Jillian can't just make a username and password and say yes. She needs to expend some resources. And this is what we mean by proof of work. So proof of work is evidence that you spend some resources. So it's kind of like when you're standing in line at a theme park and you're waiting in a 2-hour-long line just to get on that ride. So you're willing to put in that work to stand in there for your final reward, which is that ride. So in Bitcoin, or in proof of work, you need to solve a problem that's really hard. It's almost like brute forcing someone's password. And you have to do this until you find something that is close enough. And this is the sort of resource that you're expending. So if you had to brute force someone's password, that would take forever. And that's why proof of work takes up a lot of electricity and a lot of resources and a lot of time. And it essentially buys you time from people. So you're basically saying, if I'm gonna make it hard, if I'm gonna prevent double spending, I'm gonna make it hard for anyone to double spend. So if Jillian now wants to vote on behalf of everyone, she has to expend a lot of resources in order to go through with her attack. But by creating this sort of race between everyone, where they're all trying to brute force the password, Jillian doesn't know for sure that she's going to win this race. So it puts everyone on a level playing field. Like my MacBook Pro is going to be able to solve that brute force problem just as fast as your MacBook Pro. So even if Jillian has 10 identities, it's not going to make it any faster for her. Even if she has 10 MacBook Pros, it's not going to make it any faster for her, because you can't parallelize the computation. Each person has to do it by themselves. Okay, so that is the end of the presentation. Any questions? I hope you guys learned a little bit about Bitcoin, blockchain, and how the Bitcoin blockchain works and what proof of work means. And we also talked a little bit about Ethereum and smart contracts. Okay.